Good evening, ladies and gentlemen. This is your well-rounded math teacher, Mr. Picard, and today we are going to solve quadratic equations by graphing. Kind of what we did yesterday, but we're going to talk about solutions to these quadratic equations and where they show up at the graph. Solutions of a quadratic equation. A quadratic equation can have one real solution, and that's this case right here. It's where it crosses the x-axis. Now, it only crosses once here. Now, when we're talking about ax squared plus bx plus c, and f of x equaling that or y, you're talking about x squared, so it has two solutions. Well, this one only has one, but it's called a double root. And the root is another answer, another word for a solution. It just means that you have two solutions at the same point there. So if that was at like -2, you'd have x equals -2 twice. But you only really have to list it once. So they call it a double root. This is a typical quadratic function in a graph where it has two solutions. It crosses there. It crosses the x-axis. Now it's equal to 0 right now, and that's when we set y equal to 0. When we graph it, actually. So wherever y equals 0 is where your solutions are, and that's where it crosses the x-axis. So there's two real solutions. This one doesn't cross the x-axis at all, so it has no real solutions. It would have two what we call imaginary solutions, and we're not even to that point yet. So it's either one solution, two solutions, or no solutions. No real solutions, we'll say. We talked about this. Another name for solutions is roots. I guess the way I look at it is if you had x squared equals 25, how would you solve that? You take the square root. So there's two solutions still. So x equals plus or minus 5. It could be positive 5 or negative 5. Those are the roots of the quadratic equation when you take the square root. So that's why they call them roots. They also call them zeros. So solutions, you could call them roots or zeros. And the reason they call them zeros is that's where y is equal to 0. That's where it crosses the x-axis. So a couple things. Okay, so let's jump right into graphing these. I'm going to replace this 0 with y, so y equals 0. Now, when we do that, y equals x squared plus 6x plus 8. We're just saying, hey, we're looking for where it crosses the x-axis, and that's where y is equal to 0. So y-intercept, if I plug in 0 for x, you'll get your y-intercept. That's where it crosses the y-axis here. And that's where x is equal to 0. That's when you plug in 0 for x, and you'd just be left with that 8. C is 8. So when we're talking about ax squared plus bx plus c, c is just your constant, that number right there, and that's also going to be your y-intercept. Anyway, a is 1, right here. There's nothing there, so it's 1. B equals 6, and c equals 8. So we can jump right into finding your x, or your axis of symmetry, and your x for your vertex. They're the same thing. And that's where we use the formula we did yesterday, negative b all over 2a. So the opposite of b. And b equals 6 right here. Okay? So that's going to be negative 6 over 2 times a, and a is 1. So that's equal to negative 6 over 2. That's negative 3. So my x value of my vertex is negative 3. So I will put a vertical line, a dotted line, because this is my axis of symmetry. This is what we're going to flip our points over when we graph it. Well, we got to find the y right here. We don't know that. So we're going to plug negative 3 in for x up here and evaluate it. So giving ourselves a little room. Y equals negative 3 squared plus 6 times negative 3 plus 8. Well, negative 3 squared, that's negative times negative, that's positive, so that would be 9. This is going to give me negative 18 plus 8. 7 and 8 is 17, minus 18, that's negative 1. So right there, that's negative 1. So I can graph my vertex. Negative 3, 1, 2, 3, negative 1 right there. Okay, and we're going to kind of set up a table just like we did yesterday. All we got to do is find the zeros where it crosses the x-axis. So I'll put this table right here. I always start with the vertex. That was negative 3, negative 1, and I work my way, plug in x values that work towards the y-axis. So negative 2, negative 1, 0. I already know 0 is 8. So, and that would be pretty much off the graph. There's 7. It'd be right up here somewhere. 1, 2, 3, 1, 2, 3. So it's going to flip up over there. But that really doesn't help us too much because it's kind of off the graph. We'll plug in negative 2. Okay. So y equals negative 2 squared. What do we got? Plus 6 times negative 2. And then what do we got? Plus 8. Okay, so that's 4 minus 12 plus 8. 8 and 4 is 12. 12 minus 12 is 0. And that's a good thing. Negative 2, 0 is right there. That's one of my zeros. That's where it crosses the x-axis. So I write x equals negative 2. And the other one, well, that's 1 unit away. So I go 1 unit past the axis of symmetry. And there it is. There's my other one. So x equals negative 4. Some people write ordered pairs. They say, hey, there's my answers. Well, that's wrong. That's an ordered pair. Negative 2, negative 4 is this point down here, and that has nothing to do with the graph. So we'll leave that alone. I'm going to plug in negative 1 also and see what I get there, just to kind of look at what the graph looks like. I always like to do a couple points on each side. I know we got our y-intercept way up here, but that's kind of way away from the zeros. So I'm going to plug in negative 1 here. Negative 1 squared is 1. This is going to give me negative 6 plus 8. This is 9 minus 6, or 3. So negative 1, 3. 1, 2, 3. 2 units away, so I go 2 units past. And there it is. So just cleaning this up a little bit. If you kind of draw that curve in there and just hold it, it'll do like a line. Oh, that one time it didn't. Let me try that again. There we go. Okay, and then you can kind of move it around. And there we go. There it is. There's my parabola. And my zeros right there where it crosses the x-axis. Or I call them zeros. Those are also, you could write in there, solutions or roots. Same thing. If they ask for zeros, roots, or solutions, they're just looking for where it crosses the x-axis. Okay. Everything's got to be equal to 0. So I'm going to subtract 16 from both sides here. And then write those in order. I'll put the negative x squared first. Then the plus 8x, and then minus 16. I'm leaving it as negative x squared because that's what we started out with. I'm going to say this is y, but y is equal to 0. Okay? And that just means that wherever it crosses the x-axis, those are going to be your solutions. So my y-intercept is going to be at 0. Well, there's my c. That's negative 16. So that's way off the graph. A is equal to negative 1, and what that means right there, just put a little negative 1 there. As my graph is going to open down. B is 8, and C is negative 16. That's our y-intercept. We already found that. So axis of symmetry, let's find that, and our x value of our vertex by doing x equals negative b all over 2a. Opposite of b, that'd be negative 8 all over 2 times a is negative 1. So this is negative 8 over negative 2. That's going to be positive 4. So put a 4 right there. And I'm going to go over and put my axis of symmetry in here at 4. X equals 4. It's just a vertical line right there. Okay. Finding my y value. I'm going to plug everything in. That's okay. That negative x squared, you don't square that. So I'm going to put a -1 there, and there's my x squared. And actually, I'm going to square, what are we plugging in? 4. Plus, okay, I got to look up here. Plus 8x, plus 4, and then minus 16. Okay, so the 4 squared, I don't say that's, I don't multiply -1 times 4 and say that's -4 squared. That's wrong. Order of operations, think about it. You do exponents first. So 4 squared is 16 times, that's -1 times 16, then that's -16. This would be plus 32 and minus 16. Well, that's -32, -16, -16. So, you know what I get? I get 0. So, right there, 4, 0. And then this opens down. Okay, so that's my vertex, and it opens down. So I'm going to plug 4, 0 in here into the table, x, y table, and find a few. Well, I'm going to go over here, my 0, x equals 4. That's a double root, so you could put, if you want both of them, you could write x equals 4 again. And I'm just going to write double root there so we know it's a double root because it crosses the x-axis at the vertex. That does happen once in a while. So I'll graph a few more points. I'm going to work my way towards 0 on the y-axis there. So I'm going to plug in 3, 2, and that should be more than enough to graph this in. So I'll plug in, let's go y equals, I'll plug 3 in. Now remember that's -1 times 3 squared. I'll move this over. Okay, and we got plus 8 times 3 and then minus 16. Once again, I'm just plugging it in here into the original function. 3 squared is 9. 9 times -1 is -9, plus 24, and then minus 16. 9 and -9 and -16, that's -25, plus 24, that's -1. So 3, -1, right there. That's 1 unit away, so go 1 unit past it. Now I'm going to plug in 2. See what we get for another point here. And plug in 2 here and here. 2 squared is 4, so that's -4. 8 times 2 is 16. And -16 will these cancel out. I'm just going to get -4 here. So, excuse me. 2, -4. 1, 2, 3, 4. 1, 2 units away from the axis symmetry. Go 1, 2 units past it. There it is. Okay, cleaning that up a little bit. And then just graphing it. There. That looks pretty good. There's my parabola, and it opens down because it's -x squared, -1x squared. That's pretty much it. Let's go to this next one. It says solve the quadratic equation by graphing. That's what we've been doing. If the exact roots cannot be found, and they're not going to be exact roots, in other words, it's not going to cross at a whole number, state the consecutive integers between which the roots are located. So roots, they're talking about roots. They're just talking about 0 as your solutions where it crosses the x-axis. I'm going to set y equal to 0, so I'm going to substitute y in there. It's not a big deal, but y equals negative. I'll put 1x squared plus 4x and then a minus 1. Okay, so it's going to open down again. A equals -1, B equals 4, and C equals -1. So right there, my y-intercept 0, -1. Axis of symmetry, x equals, and the x value of my vertex are just going to be this. X equals negative b all over 2a. So the opposite of b, that would be negative 4 over 2 times negative 1. So that's negative 4 over negative 2. That's equal to positive 2. So let's go over here, positive 2. There's my AOS, axis of symmetry. Okay, x equals 2. Let's find our vertex first. Y equals negative, I'll put that negative 1 there. And now I'm going to plug in 2 so I can find my y value. So I plug in the 2 for x. Plus 4 times 2 minus 1. Square the 2 first, that's 4. Times 1, negative 1, that'd be negative 4. Plus 8 minus 1. So that's going to be negative 5 plus 8. Well, that's 3. 2, 3. Over 2 up 1, 2, 3 right there. And I'll just set that little table up right here. Doesn't really matter. It's away from the graph enough. Start with your vertex, 2, 3. Work your way towards the y-axis. So I'm going to plug in 1 and 0. And I know 0 is negative 1. So I can graph that right now. That's 2 units away. Go 2 units past it. I just got to find one more point and flip it, and then that should be enough to graph it. I can see between my vertex and going down, if I went down here towards the other point here, I'd cross the x-axis. So I'll be able to see where my zeros are, okay? So I'm going to plug in 1 now. Let's get rid of the 2. Just plug in 1. 1 and 1. Okay, so 1 squared is 1 times, that's negative 1, plus 4 minus 1. So that's negative 2 plus 4, that's negative 2. So 1, no, positive 2, sorry. Negative 2 plus 4 is positive 2. So 1 up 2, right here and right here. So when I graph my parabola in there, there we go. Okay, so where exactly is it actually crossing the x-axis? It's not at a whole number. It's crossing right here. Oops. Let me graph on that. There we go, right here and right here. Now this one is between 0 and 1. You could say it's like 0.5 or something like that. But we're just going to say between 0 and 1. And the other one over here is between, looks like it's between 3 and 4 on the x-axis. So you could say it's 3.5, and I wouldn't have a problem with that, but we're just going to say between 3 and, oops, sorry. And 4. So those are my answers. Or you could say x equals, it's pretty close to like 0.5 and pretty close to 3.5. So I'm not a big fan of this problem. I think it screws people up more than helps them. So we'll do this one. The highest bridge in the U.S. is the Royal Gorge Bridge. In Colorado, the deck is 1,053 feet above the river. Suppose a marble is dropped over the railing from a height of 3 feet above the bridge deck. How long will it take the marble to reach the surface of the water, assuming there is no air resistance? So basically, if this is the river down here and this is the bridge, there's 3 feet above the bridge. So the total distance from here to where that marble's dropped is, you would add the height to the bridge and the deck. So that's 1,056 feet that it's going to drop. Well, how long does it take to hit the water? Well, we're using this formula right here. H of t, which is just height, equals negative 16 t squared plus h sub 0. Where time, t, is in seconds, and the initial height, h sub 0, is the height above the water. So there's my initial height right there. So my formula is going to be h of t equals negative 16 t squared plus 1000, what was it, 56. Okay, there's a couple different ways so we could do. Well, first of all, we gotta solve for t. But what's the height? Well, when it stumbles down here and hits the water, the height is 0 feet. So I'm gonna put 0 in here, negative 16 t squared plus 1056. They kind of want us to solve this by graphing, but you could solve by subtracting 1056 and then dividing by negative 16 and then taking the square root of both sides. That's one way to do it. And that works because it's just t squared and no t. If there's a t there, you'd have to graph it. So I'm going to show you how to graph it. You can use your graphing calculator, or what I'll use a lot of times is, where is it? Desmos. Okay, there's a different little project. And just type it in. I'm going to say y equals, because h of t is like y, and that y is equal to 0 right now. Negative 16. I'm just going to go x squared. So I get a little parabola there. But I got to add 1056. Well, it's kind of off the chart a little bit. Okay, here we go. If you look at the whole thing, you'd have to squeeze it down. There's the vertex right there. And if you hit that, that's 0, 1056, right? If you plug in 0 for x, that's what it is. That's your y-intercept. But the 2 points where it crosses are your solutions. There's 8.124 and negative 8.124. Those are seconds. So we're not dealing with negative time. So my answer is actually 8.124 seconds. It would hit the ground in 8.124 seconds. And there you go. We're good to go.